Okay, well, here we go. This is our video lecture for Chapter 4. And Chapter 4 deals with biodiversity and evolution, or evolution. Just a quick note on evolution. Similar to anthropogenic climate change, people have strong feelings on one end of the other about evolution. So there are some things I think that everybody can agree on that are in this chapter, and then there are some things that people have strong beliefs on one side or the other about, and of course people are welcome to have those beliefs. So as I go through this chapter, I'm going to point out the things that I think we all can agree on, and the things that there is some debate about, and that's all fair game. Alright, so we know already that biodiversity is one of the principles, basic principles of sustainability, one of the 4 basic principles of sustainability. So let's talk about what biodiversity is then in a more formal way. We've already talked about it a little bit in class anyway. But biodiversity is something that that we're lucky to have a richness of on this planet. And that means that we have a lot of different kind of species and a lot of different kind of environments for them to live in, and it's a pretty amazing world when you travel around and you take a look at what's going on in it. So we can talk about that idea, diversity of species. So inside there are different species around, so the more species we're talking about, that's biodiversity of species. Ecosystems, as I said, we can have deserts and we can have forests and we can have mountains. And these ecosystems are diverse and different and offer different things for us as well. And even within a species, we can have genetic diversity. So not all members of the species are the same. And also the different roles that part of the ecosystems play. So there's a lot of diversity, and all of these things are connected to each other. And it's seeing these connections that we're trying to do and develop in this class. Okay, so here is a picture that gives you an idea of how some of these things play into account here. We've talked about the idea of nutrient cycling and the idea of solar energy and how each part of the cycle is important. So, we rely on bacteria, and we rely on the sun, and we rely on all these different things happening, and that's the functional diversity. The ecological diversity is the different kind of what we're going to call biomes that we have on Earth, and they offer different things to us. And then there's the species diversity, which is different species, and the genetic diversity. So the 4 things we just talked about here in one picture to give you an idea. And we'll talk about each one of those. Okay, so evolution. All right, so let's first talk about natural selection and the theory of evolution. And this was put together by Darwin and Wallace around the same time. Darwin gets most of the credit for it. But the difference between natural selection and biological evolution and how they tie into each other. So the natural selection and part of the evolution I think we all agree on, and that is that traits that are advantageous are passed on from generation to generation. And so the species can change over time depending on what traits are more advantageous. So that part I think we all agree on and can readily see examples of. Okay, so let's talk about some of these theories about life on Earth. Also, these are up for discussion too, but the prevailing belief that goes along with the theory of evolution, I should say, is that the Earth is about 4.5 billion years old. Again, people will debate that and their estimates, and nobody was around at the beginning to talk about it that's making this video for sure, or probably even watching this video, I would imagine. So we'll just go with the best estimate from the scientific standpoint is 4.5 billion years old. And that humans have only been around for a tiny tick of that time there. Very interesting that humans have only been around for a tiny tick of that time. And the idea is that it started with very small one-celled organisms in the ocean, in the sea, and then through natural selection, traits were passed on that then formed into different species. And that's where the debate comes in. Were new species formed? I think we all have the idea of an individual species evolving over time, passing on traits that are more advantageous. But that's where the big, strong difference of opinion seems to be, where some people believe that the species that we have now are the species that we started with, And the theory of evolution, as put forth by Darwin, says that species are changing over time and new species are formed. Okay, so that's the idea of this. All right, so a lot of what we know or what we've determined comes from fossil records. And so, fossils, we can see what went on beforehand, and bones are left behind, and we can put together all sorts of scenarios based on what we find. And we're refining those beliefs all the time as we collect more and more information. There's still so much that's unknown here, but that's the best we can do in some ways as far as concrete evidence of what was going on in the past. We can measure other things that went on in the past, like gases in the atmosphere, and maybe the amount of rainfall that there was, and the fossil record reveals a lot of interesting things. But again, very incomplete because we don't have fossils of everything that existed, and there wasn't written evidence, and there wasn't videotape of what was going on either way back when. So we're putting the pieces together, and I believe that we are understanding more and more as time goes on what the past was. But again, it's very incomplete, or it's somewhat incomplete now, because how can you have every fossil of everything that ever existed? Okay, so this is one thing I think that we do know, that genetics can change over time in a population. And again, these are if traits that are advantageous are passed on more often, then it's more often that the offspring will have that trait too. And after a while, traits that are advantageous will be continued to pass on, and traits that aren't will be not passed on. So the genetic population of makeup of a population can change at time. A great example is giraffes, they say. They say the giraffes once had shorter necks, but they started finding out that they were outcompeted at the lower levels, but if they could reach a little higher, they could get things that other species around couldn't get. So the theory is that after a while, the giraffes with the longer necks got to pass on their traits through reproduction. And then we have longer and longer necks, and that's where we're at right now. Giraffes are pretty amazing, but just one example of how this goes on. Okay, and that's the gist of it. That if you have a trait that is successful, that you already have, that is advantageous, you can pass that along. You can have more offspring. A modern day example is in bacteria. We use antibiotics to fight bacteria. We need some bacteria, like in the soil, to get that nutrient cycling going, and we need a lot of other bacteria too. But some of it creates diseases in us and is a disadvantage. So we have, in the modern era, created medicines that can help out fight this bacteria. So here's an example recently that we found out with antibiotics, and the thing about this is it plays out over a much shorter period of time. The regeneration is a shorter amount of time, so it's not like watching giraffes evolve over time. Human beings haven't been around that long, so it's hard for us to see these gradual evolutions happen, in front of us anyway. But here's one that we can see, and this is with microscopes, and we keep getting more intelligent with what we're doing and find more ways to understand the world around us. And these medicines are by and large great, these antibiotics to fight bacteria. But here's the example that we've been seeing, and that is that some bacteria ultimately will be resistant to whatever you're throwing at them. So you might kill off most of them, but a few survive. And since they reproduce so quickly, the few that survive will not die out, but they will be able to reproduce. And we've seen where bacteria will change over time, and it becomes really now resistant to what you've thrown at them. So there is some argument now that we're creating super bacteria that we don't have the tools to fight anymore, and partially the reason for that is because we were so successful at fighting them off before. That's a tough one to figure out what path of action to take. But again, we're collecting more information all the time on how these things work. This is a modern example of the change of the genetic makeup of a species over time. Not new species yet there. Okay, so why are humans so successful? We seem to be able to stay, live comfortably in all different kind of climates all over the world. And what have we got going on for us that has made us so successful? We've been around for such a short time compared to some of these other species. Well, we're smart For one thing, we have a brain that is able to develop in amazing ways. The ingenuity of the human mind is just incredible. Think of all that we've been able to develop and how far we've come in the short time that we've been on this planet. How far we've come in the last 100 years. It's pretty amazing. Well, one thing that got our brains working a little bit quicker was that we have opposable thumbs, and we can grip things, and we can do all kinds of things. Helps with playing video games, right? You ever see a giraffe try to play video games? I know, they got the long neck. They're not doing anything with the video games like us. But that's been a big thing for us, is the strong opposable thumbs. We walk upright, we have a complex brain, and it has set us apart from the other species. So that's it, human beings. Some of my favorite people are human beings. All right, so the adaptations that we're talking about, sometimes situations are going to change, and that is one of the things, anthropogenically or not, why we're concerned with climate change. As things change, how will that affect all the species that are here? How will it affect the biodiversity? How will it affect human beings? That's a pretty good one too. So as we're trying to adapt to changes, it doesn't have to be climate change, it could be a sudden change or something over time, there's a limit to it. The species cannot develop a trait that they think is going to help them because they now need it. It has to be something that's in the genetics of that species in order for it to be able to come out through natural selection. Okay, and another thing worth pointing out here is that it isn't the species that are, or the individuals that are the strongest that necessarily survive. It's the fittest. We're not top of, we're not the most advanced species on this planet because we're the strongest. I'm not getting in a fight with a gorilla. I don't know about you, but we have some things that are going to help us out, and it's the same with an individual species as well. All right, and this is also debatable, I suppose, but it seems to be that it's species with traits evolving or adapting because of situations that are thrown at them, not that there's a great plan for it. But that's again, a very interesting question that I'll leave for you to decide how you believe on that. Okay, here's another example that we've seen in the modern era as we have changed things on the planet. This is a pretty famous example you might have heard of. And the idea here is in England, when they started using coal, the first big fossil fuel to be utilized, they had these moths, these peppered moths, and they would see them show up in both forms, the one on the right and the one on the left. And mostly they would see the form on the right because they blended in very well with the trees there. And so they were not picked off by predators as easily, and when one of the ones on the left was there, it just showed right up and it was gone. You've probably heard this story, maybe you have. But as they started using coal, well, there's a lot of pollution that's put off by the coal, and things turned darker. And there was coal ash everywhere. They had to figure all that stuff out. We've come a long way in that area of controlling things too. And we don't burn coal as much in the cities as we used to. But, well, you can imagine, now that there's a dark covering to the trees, the ones on the right that used to be successful, they were picked off easily. And so they didn't reproduce. And now the genetic makeup of the peppered moth has changed over time. So the giraffe is a theory. Nobody's been around to see the giraffe evolve in that way, I suppose. But the peppered moth we have seen. Okay, so as I said, some of these things can happen very quickly, and some of these things happen over time. And one of the things that can happen and change things is the changing view of the Earth. It seems like we look at the map and we say, well, that's the way the Earth is, the map of the world, and this is the way the world is. But that has changed over time, and we have a good idea that that's changed over time too. Another thing, and I'll talk about it a little bit later, is that the biomes themselves have changed drastically. But there's always movement going on, even though we don't notice it. The idea of movement and things that are going on underneath the planet affect us in a big way. That's where we go after the fossil fuels that are so important to the way we live and the history that we have that's brought us to the present that we have now, those fossil fuels, under the ground. And the movement also, it's dramatic when there's an earthquake, when there's a volcano, but there's always movement going on, and gradually over time, that has moved and separated areas, and they can separate members of the species, and change the way things are working for them, and that can affect the evolution. And also, if you're moved to a different place or a different climate, now different traits are going to be helpful within the species too. And if those traits that were once not helpful are now helpful, those individuals will pass on their traits. Natural selection, right? Okay, so volcanoes, you can imagine, they put a lot of stuff up into the air. With the lava, they kill everything that's going. They wipe out everything that's going on. The life changes very quickly in that area, and depending on how many members of the species you have, you got to remember too that some species live in only a small area. So this can be very disruptive to the entire species if they live in only a local area. So that can affect things, and also the volcanoes can affect the climate as well. So now individuals that can handle the new climate have an advantage over ones who can't quite handle the new. Well, remember we talked about that with the zone of tolerance earlier. Okay, so the idea here is that we have evolved from where we were. So if we were all one big clump of land and then we separated, of course there's going to be some kind of isolation going on, and that'll change the species. And this idea of climate change also, like I said, the zone of tolerance can change the individuals that are going to be okay. Some species might not be able to handle the new situation, and then they could go extinct, right? So we know about these kind of things. This idea of climate change is not new. This is one of the reasons the discussion goes on whether humans are causing it or not. I think we're all in agreement that climate change has happened different times in the history of the planet. So what do we want to do about it? What can we do about it? And what have we done to cause it is really pretty far up for debate, but it definitely affects what's going on. And it's good that we all know all sides of the issue, I suppose. So through the fossil records and through the idea of being able to carbon date things, and also through the idea of ice rings, which are somewhat like the rings on the trees, which they indicate what they grew in each successive year, and also trap in the gases, we can get an idea, a little bit of a picture of what life was like while that was changing, while the temperatures were changing. Very, very interesting. Okay, so a big collision can cause things. It's going to change. It can put so much stuff up in the atmosphere that the climate is going to change. That causes extinctions, and we know, or we're pretty well convinced that that has happened in the past, and we want to see how that informs what's going on currently and into the future. Okay, the Earth that we have right now, pretty darn good. It's got a temperature. It's able to hold in the atmosphere that we have. It's got a temperature range that supports all this life that seems to be able to work interconnectedly. And just the way that we have different seasons affects the idea of the flow of air. It's not static. There's a flow of air going around, and that's because we're tilted on our axis. So when at different times of year, the sun being here, different areas get different amount of sun. Because of that, and the rotation that we're constantly spinning here, we're tilted and rotating. Because of that, we always have winds that are carrying things from one place to the other. We need a lot of water to survive, and we have a lot of water. And this is a pretty good setup for us. This Earth here seems to be just right for life as we know it to thrive anyway. Okay.